So good afternoon, and thank everyone for attending our fifth UK&I Ireland Enablement Series webinar. My name's Carl Bavington. I'm one of the Solution Architect Managers here at VMware by Broadcom, and today we're going to hear from Richard Jones, one of our specialist SAs about NSX and VPCs. But before I hand over to Richard, I'm sure everyone's aware of VCF 9. We spent quite a bit of time talking through it in the June webinar with a link to several resources. So if you weren't able to join that call, I'd suggest to go back and rewatch the replay. If you don't have time for that, I would say the one-stop shop I'm recommending people to is the What's New in VCF 9. And then from there you can go off and do further research for additional resources. And over the coming months, we will delve more and more into the specifics of a feature on VCF 9. Just a bit of feedback on the surveys, which you all kindly fill in. We had a few questions come up during the last session and a few questions in the chat around Holodeck and a little bit more as to what that is and how we can utilize Holodeck to build out a nested environment. So we have a few sessions coming up, but I will look to try and get scheduled before the end of the year, so before sort of December's session, a dedicated webinar on Holodeck. But just before I hand over to Richard, I hope you've been able to register for the Explore on Tour in London. The numbers are ticking up nicely. Since we did the registration page, which opened, I think it was on the 9th of July, the price, and I know this is for various different, I know we have a few people join us from various parts outside the UK, but it's £198 sterling when you go through the registration page. So if you haven't yet registered for Explore on Tour, I encourage you to do that. The numbers are ticking up quicker than I expected. So in order to secure a place, go through and register for that. As usual, it includes the food and beverages, backpacks, but the one thing which people aren't always aware of is this year it's going to include a free certification exam. So as you go through the registration, just make a note of the details of what's included that, because obviously a certification exam is valuable and useful to have. So during the session, feel free to ask questions in the Q&A, and we'll do our best to answer them live during the session. So at that point, Richard, can you just please briefly introduce yourself and kick us off?
Yeah, good afternoon, everybody. My name is Richard Jones. I'm one of the solutions architects in VMware by Broadcom, focusing on VCF networking, formerly known as NSX. But if you're not aware that NSX was sort of split out into two different products, one is the VCF networking product, which comes as standard with VCF. And then obviously the other part is the security, which is part of the vDefend portfolio, which is effectively an add-on to NSX. And in terms of getting vDefend, you have to have NSX deployed and installed and configured across your host. So today's session is going to focus on multi-tenancy with VPCs. VPCs have been in the product probably around 18 months or so, but with obviously the release of VCF 9, we've added some additional features and enhancements, which I'll cover off today, both in slides, but also in the form of a demo as well. So a little bit on me, based in the UK, so Hampshire in the UK, been in the industry for 30 plus years, but yeah, worked in VMware for about 10 years, but prior to that, very much focused on physical networking and switching and routing, mainly on Cisco products, but also across other vendors as well. So that's me. There's my email address there in terms of the contact. So if you've got any further questions on the slides that we present today, then do reach out. We'll sort of get back in contact with you, and then maybe arrange some further sessions with your account teams. So if we look at, I suppose, where VMware has come from, right, in terms of a networking background, we sort of started off, I suppose, in the early days, obviously with vSphere, but also with the sort of the standard switch, right? So we had the standard switch, where you can configure port groups, ultimately trunk VLANs over those port groups, and then attach your virtual machines to those port groups. We then evolve that into what we call the distributed switch. So obviously where the same configuration is done at vCenter level, and then that's pushed across all of your hosts within a cluster. So obviously that means that you can maintain consistency across your hosts, across your VLANs that you're presenting, and ultimately your workloads don't become isolated because you don't have the relevant networks at a host level. And then obviously we acquired sort of Nicira, sort of 2012, and then obviously that produced NSXV, so NSX for vSphere. And then we released sort of 1.0 of NSXT in 2016. So I suppose if you sort of jump forward with every sort of major release that we've had of the product, there's always been enhancements and feature upgrades and improvements that we've made to the product. And obviously up to 2025 now, obviously with the release of VCF 9, we've now added some additional capabilities. But the one we're going to talk about today is projects and VPCs. Okay, so not sure if you're aware of NSX as a product. I appreciate there probably are some people on here that have got NSX or have seen NSX, but we're probably going to have a number of people that haven't seen the product itself. So ultimately, NSX is a software-defined networking capability. It's decoupled from the physical hardware. So ultimately, everything is delivered in software, enabling you to provide sort of self-service networking, providing distributed routing and switching capabilities at a kernel level, and then allowing you to have consistency across your workloads. So both network consistency, so ensuring that your networks, your subnets, your VLANs, or your overlay networks are presented in the right places, obviously consistently, but also around security as well. So if you've got workloads that you're securing with the vDefend part of the product, making sure that if those workloads are moving around, because they will, because you're enabling things like HA and DRS across the clusters, that you've got consistency across those workloads. NSX can also be used for simplifying Kubernetes networking as well. So building inside the platform itself a comprehensive sort of portfolio of features. So you don't have to go out and sort of do a do-it-yourself, build your own Kubernetes sort of stack for networking and security based on sort of open source. It can all be done inside NSX. We've then got some monitoring and some troubleshooting capabilities with the advent of, I'd say, VCF 9. A lot of those are being built into VCF Ops, but we still have operations for networks as well, so formerly known as Verni, amongst other names. So we've got that tech capability to enable you to sort of troubleshoot, fault find, and gain that visibility into what's going on both in the overlay networking, so both in NSX, but also in the physical infrastructure as well. And then workload mobility, so the ability to stretch layer 2 networks within a data center or across multiple data centers, enabling you to retain IP addresses of virtual machines. So if we need to invoke DR or disaster avoidance, disaster extensions, network extensions, then we can do that, but retaining the IP address of the virtual machine. So we don't have to re-IP address machines. We don't have to update firewall policy, DNS records, those sorts of things. Ultimately, the workloads will recover dynamically. And then, as I said, the lateral security piece is around the vDefend portfolio. So stateful services, also the addition of advanced threat prevention, IPS IDS capabilities, sandboxing, network detection and response. A lot of that has come from an acquisition of a company called Lastline a number of years ago. So if we look at, I suppose, the private cloud and we look at, I suppose, how VCF networking can help, I'm not going to read all of these out, but it is around these sort of 4 pillars, right? Simplicity, availability, scalability, and consumption. So how can we build repeatable patterns, right? How can we avoid, I suppose, having to go to the networking and the security team, ask them to make manual changes to the physical network that they've obviously been doing, which obviously causes some constraints, right, around sort of time, how we can actually get our workloads and our applications out servicing our customers and our clients in a much quicker way. How can we sort of, I suppose, normalize the compute, right? So how can we sort of standardize on what we're doing around delivery of the compute infrastructure? ultimately, we don't really care about, I suppose, what x86 architecture you're using. It could be sort of multi-vendor across different data centers, but we can provide you with this layer of abstraction. Availability really lends itself to that IP mobility piece, right? How can we actually make sure that our networks are extended across our data centers to help us with disaster avoidance and disaster recovery? Scalability, about pooling capacity together. So how can we pool all of our capacity together rather than having to have sort of separate silos of capacity for maybe test and dev, pre-prod, production? How can we scale the environment? So if we're adding additional hosts to the environment, we're then going to get that additional capacity, right? We're going to get that additional in-kernel capacity around the routing, but also things like the firewalling as well. And then consumption, right? How can we make the NSX, I suppose, and the software-defined networking easier to consume, right? And obviously, we've got integrations with what was obviously ARIA automation, which is obviously VCF automation now. And we've got integrations, obviously, with a number of third-party vendors as well. So you can use things like Ansible and Terraform. And then the one at the bottom there really is, I suppose, the one we're going to talk about today, which is projects and VPCs. So just a little bit on NSX, right? We start off with a physical infrastructure. Obviously, we can't get away from that. We still need a physical network. The only two requirements of the physical network are IP reachability between our hosts and support for sort of larger frames. So as long as your physical network can support jumbo frames, then ultimately we can stand up an NSX platform. So we can deploy NSX, we can roll out all of obviously the modules that come with that. And then that gives us this sort of virtualization layer where we can then embed other capabilities alongside the virtual distributed switch. So whether that's the virtual distributed routing, so routing sort of done at the source within the hypervisor, the switching, so the stretching of the layer 2 network over layer 3, the distributed firewalling capability and gateway firewall, and then integrations with sort of both the native load balancer, which has a certain sort of set of use cases, but also integration into the likes of AVI. So the NSX, what was the NSX Advanced Load Balancer, which is now obviously been rebranded back to AVI. And then ultimately providing services not only to our virtual machines, but as I said earlier on, but also to our containers, right? So we can make containers sort of first-class citizens of the environment, and obviously they can consume those networking resources as well as the virtual machines can. So ultimately, the stack is a pretty full stack. So as I say, we've got the routing, the layer 2, the load balancing capabilities, connectivity to physical. So when we want to go from virtual to physical, how we do that at a layer 3 level, but we can also have bridging as well. So we do support some bridging capabilities. And then things like, I suppose, supporting features like NAT and DHCP, and then the security features around the IPS IDS and the firewalling. And as I said, that really lends itself to driving NSX from a number of different developer tools, right? So when we talk about DevOps, obviously there's a number of integrations here, obviously, which you'll appreciate, and obviously you'll have a good understanding, I suppose, of some of those logos, right? And obviously that's where we can integrate directly into NSX and ultimately providing you a cloud-like experience. Okay, if you don't have an SDN, you can't effectively deliver a private cloud. Okay, so when you go to public cloud and you request something like a VPC or a VNet from an AWS or an Azure, ultimately it's all delivered in an SDN, right? So they're providing you the network, they're providing you an enclave, they're allowing you to connect your virtual machines to networks and then secure those networks, right? All of that is delivered in software. So what we're going to talk about today is how we can do that on-prem, right? How we can do that in the private cloud. So without further ado, let's talk about VPCs. So in terms of a definition of a VPC, ultimately it's all these things, right? So it is about being able to isolate the virtual networks. It is about being, obviously, I suppose, able to scale and having that elastic scale, provide a simplified consumption model, right? So how can we make this easier for the consumers to ultimately create virtual private networks so they can actually consume them? And how can they manage those environments themselves, right? And then obviously that then lends itself to, I suppose, the adoption of sort of self-service, both from, I suppose, an NSX perspective, but also an automation perspective, right? How can we also make self-service available when we're automating this, actually, how can we just make sure we're just targeting our own little bubble, our own little area? And then obviously, how can we provide this, I suppose, across multiple clouds? So if we're providing this across our private cloud, how can we then stretch that across our multiple data centers that we might have to ensure that obviously we can still retain all of our connectivity and our VPCs continue to function if, as again, we need to invoke something like disaster recovery or disaster avoidance. So NSX itself has lent itself to, I suppose, multi-tenancy over time, right? So we've always, within the product, had native isolation, right? So native isolation around things like the distributed firewall, the gateway firewall, where we can put security groups and effectively wrappers and bubbles around certain types of VMs. And then obviously we can control the traffic flow between those different VMs within those different groups. We then, at a data plane level as well, we've had obviously separation around having separate VRFs within the environment or separate edge nodes that support separate T0s and T1s. And we're providing, as I say, that layer of separation at the data plane, right? So that is all done at the data plane. And then you're effectively providing that separation, whether that's, as I said, a test dev, pre-prod, production, whether that's going out into your physical network and actually still meeting that separation criteria when it exits and going to maybe different top of rack switches or into different VRFs on your physical infrastructure or into different firewall context. Obviously, we've been able to provide that separation inside NSX. And then I suppose layering on top of NSX, so rather than having to drive NSX manually or through direct through the API, we've had this layer of abstraction where we've used a cloud management platform. So actually the cloud management platform then provides some multi-tenancy. Different users log into the cloud management platform, and then they, in the background, they're creating blueprints, they're creating their workloads, and then they're delivering networking and security services, right, via that cloud management platform. Or like it says, they're all using separate NSX managers to provide that, again, that layer of separation. And then I suppose logs and alarms, the only way to really provide separated logs and alarms has really been to provide separate NSX managers, right? So it's all been fed into a single sort of log management platform. But now with VPCs and projects, we can now send logs that are relevant to those VPCs and those projects to their own log systems, their own log servers. So what is a virtual private cloud? As I said, I've already sort of talked about it really. Effectively, it is a cloud or a bubble or an enclave or whatever you want to call it, where we're providing subnets. So we're providing networks. So we're providing subnets that can be discrete, right? So we can provide effectively private subnets that can be accessed only within the private cloud. We can actually also provide subnets which are accessible by the public. And then we can provide subnets which are accessible within the VPCs themselves. Okay, so lots of different capabilities. We can also then provide security as well. So we can actually use the distributed firewall to build in security policy around our virtual private clouds. So we can, again, further secure them, not only from the fact that actually they're inherently secure anyway, because unless we provide any external connectivity, they're contained, but we can also put security around our workloads. So we can also create them via the UI. So we can go into the UI, both of NSX, but also you will see a vCenter, and we can create these VPCs. We can also create them through automation. And as part of the demo, I will show you effectively, obviously, both options, right, when it comes to obviously creating them. And then obviously you can create multiple VPCs within an infrastructure, servicing your tenants, right? So it could be at a top level. You have obviously the enterprise admin, which will be overly responsible for the NSX environments. We can then disseminate roles and responsibility down to what we call project admins, and then ultimately down to what we call VPC admins. And then, as I said, the VPC admins log into their own environment, whether that's into vCenter, where they can see their own workloads, and then they can consume the networks, and then they can log into NSX itself or target the API directly using their own credentials. So they're only interfacing and actually making changes to their own VPC. So this is really what it looks like, right? We're going to have obviously virtual machines within our VPC. We're going to have subnets. those virtual machines are going to sit across different ESXi hosts, right? And again, this is really underpinned by VCF, right? So this is a VCF deployment. We're using vSphere. We're using vSAN storage, but obviously there are other options around storage. And then, as I say, we're using NSX networking. So you can see here we've got two SCXI hosts, two VMs on two different hosts. And then off the back of that, obviously, we've got our underlying networks, right? So we've got our management network, we've got our vMotion, we've got our vSAN, and then we've got our NSX networking, right? So this is where we start talking about things like tunnel endpoints, TEPs. This is really where we're stretching that layer 2 capability over a layer 3 network. So you can see here, our layer 2 networks are stretched between hosts, but these hosts could be within the same data center or they could be across different data centers, right? The options are there to actually be able to achieve that. We then have this VPC gateway. So effectively, a VPC gateway is created when you create the VPC. And then that VPC gateway is then responsible for doing the routing between the various subnets within the VPC itself. So you can see here that obviously our web server wants to talk out onto the application network. It goes through the VPC gateway. And again, that technology is built using effectively these tunnels, right? These tunnel endpoints using the overlay encapsulation that we've got within inside NSX. So you can see there that obviously the traffic there has been completed between our web and app using our overlay technology. So ultimately, it just means that we've got connectivity within our private clouds. And as I say, we could stay within that private cloud. We don't have to build external connectivity. But obviously, if there is a requirement to have external connectivity, then we can address that too. So if we just look at, I suppose, the roles and responsibilities from an NSX perspective, and you can see the key at the bottom here, we've obviously got blue, which is dictated by the enterprise admin, dark blue, then we've got green for project, and then we've got a lighter blue for VPC admin, right? So ultimately, we've got the physical networking admin, right? And there is always going to be some interaction if we want to talk externally between what we do inside NSX and obviously who administers NSX to obviously what we do out when we go outside to the physical network. But a bit like, I suppose, if you've had a talk track around NSX, the changes on the physical network, yes, they are one-time only configuration tasks, but they will be minimal, right? We then have the NSX Enterprise Admin, okay? So he's then responsible for obviously obtaining the resources and the configuration from the physical. We can then go in and create projects, and you'll see that we've got a couple of projects created. So we can give them, for example, obviously Project Coke and Project Pepsi. We can then allocate resources out, right? So we can allocate out quotas to our projects. So ultimately, this really is a safeguard so that our projects don't go in and consume too many resources of the environment, and ultimately don't obviously consume too many resources that ultimately it breaks the environment. So we can put a number of guardrails and quotas around that. The project admin is then responsible for creating the VPCs, right? So you can see here that within a project, we can have multiple VPCs. So once they've created the VPCs, they again can allocate quotas within their quotas of obviously what resources the VPCs can actually assign to their own workloads and their own environments. And then really we have the VPC admins. So the VPC admins, they log into their VPC, and then obviously they can control things inside their own environment where they can create these networks. They can create DHCP policy, they can create NAT policy, they can create security. So they've got a number of things that they can do within their own environment. So we also have this concept of a transit gateway. Now, this has come sort of as part of VCF 9, and the transit gateway is responsible for interconnecting VPCs. So if you've got a requirement where you want VPC 1 to talk to VPC 2, you can do that through the transit gateway. The transit gateway then also provides the connectivity to the external network. So again, that's how you do the P2V connectivity and how you get out of the virtual environment out to the physical environment. One thing you will notice if you are used to NSX and you're used to driving NSX, typically what you're used to seeing is T0s and T1s show up in the UI, right? VPC gateways will not be shown in the UI. They will not be present. They are effectively a T1 for all intents and purposes, but they are not visible within the actual UI itself, so you won't be able to see them. And then obviously we have these uplinks effectively from the VPC gateway to the transit gateway. And then obviously we have the interconnecting subnets. And then obviously those subnets are where the virtual machines are going to connect. So this really gives us, I suppose, an idea of the networks that we've got within a VPC itself, right? So we have a private network on the left-hand side, where we don't have any NAT. So this is a VPC gateway, sorry, private subnet, where you can obviously talk to VPC1, talk to VPC2 through the transit gateway. Okay. If the one in the middle, they want to communicate, ultimately they would have to do that through the private network. So there's a private address range. And then the third one there really is obviously a private VPC block, where you've got a private network. And if you want to be able to talk to the private network in orange on the right-hand side, you would have to NAT that connectivity. Okay. So three different options, ultimately providing you all of the connectivity you would need within a VPC network itself. So if we just look, I suppose, models that we've had in the past, so you should be used to this. This is the vSphere model, physical network with inside vSphere, creating distributed port groups, ultimately delivered by the vCenter admin. And then obviously we need some work done by the network admin, right? He needs to create the VLAN and the switch virtual interface and the gateway, ultimately for that distributed port group. We've then got a model here where we've added NSX into the environment. So we've got obviously the vCenter admin, and then obviously we've got the NSX expertise in, right? So we're now connecting that VM to an NSX segment that obviously then talks through a T1, through a T0, out onto the physical network. And again, this assumes obviously that the one-time only configuration task, the physical to virtual, has already been plumbed in, right? That's already there. This is really adding additional VMs or additional applications to the network, right? So again, abstracted away from the physical network. This is obviously where you've got a vCenter admin with obviously no NSX expertise. So obviously we've got the NSX segment. And then obviously we've got two segments there with which were created in NSX, and then obviously we've got a VI admin, right? That obviously doesn't really know the environment, so obviously he needs to communicate with the NSX admin to provide that connectivity. And then the new model really is around the VPCs, right? So again, this has been in, I suppose, the product for about 18 months, where we've had connectivity to the physical network. We've been able to create projects, and then we've been able to create VPCs, right? So this has all been done inside NSX itself. And then with version 9, we've now got this model where we don't even need to go to NSX. We can create all of this outside of NSX. So you don't need any expertise from an NSX perspective. You can actually just go in and create VPCs within the environment itself. Again, there will be obviously some work required by the physical infrastructure and the physical network, but again, it should be very minimal and it should be very light touch. But once it's done, you don't then need to revisit the physical network itself. So the transit gateway is new in VCF 9. It does belong to a project, so the project admin. So in this case, the project admin would own the transit gateway. He can provide a number of we've got a number of external connections that the enterprise admin would provide. Once he's provided those external connections, we then effectively connect the transit gateway to one of those external connections. So depending obviously on your requirements and obviously where you ultimately want your traffic to exit out onto the physical network, which would be dictated by which external connection you would use. And then we've got a couple of different models. One, we've got this centralized model for a transit gateway, and the centralized model is based on edge nodes. So if you're used to NSX edge nodes, ultimately those NSX edge nodes form an edge cluster, which then ultimately provide you the P to V connectivities, the virtual to physical connectivity. And ultimately those centralized edges run as active standby or active. So depending on what requirements you've got, and as I say, we've got a slide a bit later on which will show you that, might dictate which centralized deployment model you might need to go for, right? Depending on, let's say, what requirements you've got around things like DHCP, NAT, firewalling, for example, right? So if you want sort of stateful north-south firewalling, then you'd have to look at an active standby model. And then we've got this new concept of a distributed model, right? So where we effectively have an edgeless deployment. So effectively, the transit gateway talks directly out to a VLAN. And then that VLAN has a gateway and obviously a subnet associated to it to provide that external connectivity. And as again, that will become clear as we go through. So the transit gateway, again, like I said here, is associated with a tier 0. So if that's running on an edge node, you would tell the transit gateway to peer effectively with the tier 0. Once it's done that, it effectively will auto plumb the configuration and the connectivity, right? So it will do all of that for you in the background. And then, as I say, yeah, it will link effectively the transit SR gateway, so the services router, to the tier 0 services router. So it will effectively build a routing adjacency between the transit gateway and the tier 0. Again, if you want an active standby deployment, these are effectively what we support, right? So we'll support external IPs, one-to-one NATs. The biggest ones in here, really, if you're going for centralized, would be north-south firewalling. And then obviously things like NAT capabilities around sort of source NAT, destination-based NAT. And actually centralized deployment is a must if you're looking at a supervisor cluster. So if you're using things like VKS, then you would have to look at doing this through a centralized model. In terms of an active-active, you've got a couple of the options there obviously are shorter in terms of the features. So you've not got as many feature available in an active-active. But it may well be that an active-active is good enough for you and it lends itself to obviously your use cases that you might have. But again, you can't use this if you're looking at sort of supervisor clusters and VKS, right? It would have to be an active standby deployment. And then, yeah, so in terms of the distributed gateway, this configuration is done, as I said, within vCenter, right? And this is where it differs from having an edge deployment. This is an edgeless deployment. So you can see here out on the physical, we've got a physical router, we've got a subnet allocated to it. It's a VLAN as well, and it's got a subnet and then a default gateway, which would obviously be 10.0.0.1 on that physical router. We then deploy effectively the transit gateway, which is distributed across our hosts. We still use the same interface that the TEPs use. So we're still using obviously the tunneling endpoints to route traffic within the VPC. So obviously within the subnets that are attached to the VPC. But then ultimately the external connectivity over the transit gateway will use the same interface that the TEP interface is using. And then obviously, again, we've got obviously the external blocks, the public subnets will be taken out of the external blocks that are defined by the enterprise admin. Okay. Obviously, we'll reserve some IPs, right? So obviously, ultimately, what we don't want to do is serve out, if we're using DHCP, obviously the gateway address, right? We'll be in all sorts of trouble if we do that. And then obviously the ESXi host is responsible effectively for the ARP requests from the VMs in the hosts themselves. So ultimately, we're using proxy ARP at host level to obviously fulfill obviously the connectivity from the VM out to the physical network. And then what we can do as well is if we've got a private subnet, so this is a private subnet which isn't accessible from the outside world, we can effectively have an exposed one-to-one NAT. So we can provide a one-to-one NAT using the public addresses and then obviously NAT into that VM that's sitting on that private subnet. Okay. And then yeah, east-west traffic is still serviced by the tunnels themselves. So I suppose in summary, these are the capabilities that you'll get through that transit gateway. But obviously, yeah, just be aware of the things that obviously that cannot run when you're using the distributed model. So this is how it's realized in vCenter itself. So obviously this is a VCF 9 deployment. Effectively, we go to networks as part of the vCenter. We then have this network connectivity tab. We click on that. We've then got the two options, right? Whether it's centralized or distributed. In this scenario, we're just going to use distributed. We're going to select this. So we've gone through the prerequisites. We then define the VLAN that we're going to use, obviously the gateway address that's going to be used. We then define the block. So we're saying it's a /16. And then we're defining effectively the private transit network, right? So this is obviously the network blocks that we're going to use inside NSX. So effectively what we've done there, we've carved out obviously two big networks, right? 2/16s. But when you go in and create the VPCs, what you'll request is creating, when you create the subnets, you'll request how many IP addresses you want allocated for each subnet. And again, all of those can be controlled by the guardrails and the quotas that will dictate basically at a project level, but also at a VPC level as well. Once we've done that, ultimately, yeah, we've now got VLAN 10, we've got the gateway address. So that's really as simple as that. As I said, there is some interaction with the physical network. Yes, you do need to do some work to get to that point, but it's very minimal, right? And again, it's a one-time only task to actually go and do that and request the interaction with the physical network. If we look at, I suppose, a deployment where we've got an edge deployment, so we've got an edge cluster which we're using as the resources. Those resources then can then be consumed by obviously the projects themselves, right? And then obviously by the project admin down to the VPC. So again, if you want to run some services and you want to run effectively north-south services, you want to run things like the gateway firewall, NAT, then ultimately you have to go for this edge deployment, this centralized service. Okay. So that's just a bit of, I suppose, a recap on where we've got the features and the functionality across the three different models, whether it's centralized, whether it's active standby, active, or obviously that distributed model. Yeah, these are just some of the examples of quotas. So you can see here that obviously the enterprise admin defines a number of different quotas down to each project. And then obviously the project admin defines the private blocks that the VPCs can use. And then again, the project admin is then responsible for defining additional quotas to the VPCs themselves. Also, VPCs are in VCF automation. So again, if you're looking to deploy or use NSX, but obviously from an automation perspective, then VPCs are in there. So ultimately, you can deliver VPC networking, with inside, VCF automation, or obviously using another tool if you've got a tool of choice. I'm assuming at some point there'll obviously be a sort of a Terraform provider which includes this, and then obviously you can use things like both Terraform and Ansible from that perspective. But then I suppose it lends itself to again really building that consistency around the cloud admin, network admins, but also from a self-service perspective, both for VMs and Kubernetes. So these are capabilities that we don't have in VPC. So if you're looking at any of these and you've got use cases around any of these, then we don't have that capability to date, right, around some of these technologies. And then the other point I was going to mention really before I go into the demo is everything is still owned by the NSX manager. Even though you'll see in the demo, you can control things and you can push things from the vCenter, effectively that is just a plugin, right? It is a plugin to the NSX manager and all of the configuration is still stored on the NSX manager itself. Okay, so nothing is saved in vCenter, everything is stored on the NSX manager itself. So at that point, I'm just going to break into a demo. So let me log into the vCenter. So log in there. I'm just going to log into NSX Manager as well. So like I said, what you can see here really is if I show you obviously the vCenter, we've got a number of applications in here. We've got a finance application, we've got a marketing application where the VMs are powered off. And then we've got effectively a project as well called App One, right? So what I'll show you quickly, and as I'm only going to take 5 minutes here, just to show you around some of the technology. You can see here, if we look at the VM itself, and we look at the vCenter, under networks in here, you can see the network connectivity, right? So the thing I just showed you as part of the slide, you can see here we're using VLAN 30, and we've got an allocated range that we're using, which is 30.30. And then obviously this is our gateway. So this is obviously our device that we're potentially going to be using out on which we're really using out on the physical. You can also see in here, these are a number of obviously VPC subnets, and then obviously we've got a couple of VPCs defined. So again, all of this information here is being pulled from NSX, right? It doesn't exist inside vCenter itself, right? So you can see here, I've got a virtual private cloud. I've got the VPC here. So under virtual private clouds, this is where you define them, right? So I could create myself a new virtual private cloud in here. Obviously, in the interest of time, I'm obviously not going to be able to do that today, but this is where you would go in and then obviously you could define what that virtual private cloud looks like, what the private CIDR range is that you're using, what services you're going to use. Again, obviously, we can't use north-south here because we're using this distributed model in here. But you could obviously create a new private cloud, obviously, if you had that use case. And then what we've got is, as part of this VPC finance, we've got a couple of networks, right? So you can see here, we've got a public range. You can see here, it's effectively an NSX network. So it's an overlay network with obviously its corresponding virtual network interface in here. And then we've got a private IP address range as well. So again, you can sort of see in here, obviously you can see which VMs are attached. So you can see on the private range, I've got the database. In the public range, I've got the web server. Okay. The other thing to note in here is around, I suppose, if I look at this VPC finance and I look at the permissions, I've got this LDAP group, which is called Group Dev Finance. Okay. So that just means that if I log in as an AD user and I'm a member of this group, I will get access effectively to my VPC, and I'll show you that in a couple of seconds. So what that really means is we've got this VPC, we've got a number of subnets allocated to it, and I can effectively show you what that looks like. When I click into, configure, I can show you a topology. Okay, so I can show you a topology of what my VPC looks like. So you can see it's got the external connectivity up to effectively the physical network. But then these are the subnets that are allocated. So obviously this is the allocated private range, and then we've got the allocated range from a public perspective. And then obviously we've got the VMs that sit off the back of that obviously we can look at, and we can sort of view details about the VM. We can have a look at the IP address and so on and so forth. Okay, so ultimately what that then means is that we've got effectively some workloads, right? So I can now click on my finance app, and you can see I've got connectivity to my finance app. If I just show you what that looks like, if I log out of here and I log out of administrator, because obviously administrator can see everything. If I effectively log now back in, it's going to log in. If I now log in as effectively developer one, so I'm now logging in as a member of obviously that finance group. Okay. So you can now see, I can only see a subset of things, right? I can only see the applications that are obviously assigned to me as part of my user credentials. But what I can do is I can go in and consume obviously the networks that are allocated to me. So off the back of here, we've got a couple of networks. We've got the private finance, and then we've got the web finance. Okay, so you can again see that I can only, say, administer what I can see from a vSphere perspective. If I log in here as well, so I'm going to again log into NSX as developer one. So again, I've got access to NSX. I'm only going to see my VPC, right? So I've only got access to my own virtual private cloud. So I can look at my topology. I can go in again, because I'm the owner of this. I can go in and edit this. I can modify and make changes to my own VPC, but obviously without compromising obviously the entire NSX environment, right? So the other thing is I was just going to quickly show you as part of the demo is an automated deployment, right? So what we've got in here is I've got effectively a PowerShell script. So the PowerShell script is effectively going to create me another VPC. But what it's going to do, it's also going to connect my networks that I create as part of that VPC to the marketing and to the web database apps, okay, as part of that deployment. So if I just log back in as the enterprise admin, you can see in here, just going to log back in here as well. Yeah, you can see in here, I've only got VPC Finance, which has been created through vCenter. I do have another project here, though, which is created from NSX. So even though you can still do this VPC creation from vCenter, you can still drive all of these things through the NSX UI or API itself, right? So you don't have to use vCenter going forward, obviously for VCF 9, if obviously you don't want to do that, right? And you want to continue using NSX to drive the configuration. Okay, so just going to run this PowerShell script, fairly basic, but what you'll see, you will see it start building, right? So if I go back to here, as part of the deployment, you will start sort of seeing it creating a project inside here. I refresh. So you can now see I've got this VPC marketing, right? And now I've got effectively the marketing DB and the marketing web. And then you can see as part of the tasks down here, it's powering on the virtual machines, right? So you can see that it's powering on the virtual machine DB, and obviously it's powering on the web one as well, right? So you can see, again, you don't have to drive everything through the UI. You can still drive everything through API or through script to obviously enable you to create these VPCs themselves. So that's there. Ultimately, I'm not sure whether the application is there at the moment, but now still waiting for it to tick along. Obviously, it's going to be allocated this IP address. We'll come back to that in a second. But what I'm going to show you in here is part of NSX. Projects that are created in vCenter are created as part of this default project. And then you'll see in here, under private clouds, you'll see the two that we've got allocated out, right? But again, can't administer them from here. We would administer these from vCenter itself, okay? What we've then got is we've got additional projects. So we've got this additional project in here, which obviously contains this VPC project, okay? So obviously this project in here. The other point to know, and as I said earlier on, you don't realize the VPC gateway. So you can see in here, even though I've got connectivity, even though I've got virtual to physical connectivity, even though, yes, under the hood, it's using T1s and T0s to gain that connectivity out to the outside world, these aren't in here, right? So there's no tier ones. But we do obviously have the default transit gateway. So that's in there. And obviously that's providing that connectivity out to the physical, right? And then obviously in here we've got some additional ones where we've got the external connectivity, which I showed you before, but within vCenter itself. And then hopefully, now our marketing application is up and running. So that was really it. A bit of a whistle-stop tour, I suppose, around sort of VPCs and obviously the capability. But hopefully, if it's whet your appetite to know a little bit more, then please get in touch and reach out. Thank you, everybody.
Perfect. Thank you very much, Richard, for taking us through VPCs today. That was a seamless set of live demos. So I think we've been very blessed with this. Yeah. So if you've got any questions which haven't been answered, we'll look through those. We do keep a copy, and we'll get back to you. Hopefully, you've recorded everything in the Q&A. It looks like we've got a good track of that. So thank you for doing that. Can you also please fill in the survey? We do read through them. We do take the feedback. As I mentioned at the beginning of the webinar, we'll look to do something on the holodeck because we had a few questions around that. The next webinar will be on Friday, the 29th of August. I appreciate we are getting into the holiday season. And if you're unable to make that, which I appreciate a lot of us will be out, as usual, we'll have the recording. I know there was a Q&A question which came up for it, and we've posted it in the chat. So feel free to go back and watch any of the previous recordings or go back over Rich's session today. So feel free to utilize that. Just another call out for the VMUG UserCon, which is the day after the Explore on Tour. You do need to register for this separately. So I know I've mentioned it over the last couple of the webinars, but it is important that's separately registered for. It is a free event, and there is still a call for papers. So if there's something you've been working on which you want to share with the community, you spend quite a bit of time working out how to build or solve a problem, then that's the sort of sessions the VMUG are really keen to hear about. So feel free to utilize those QR codes on the screen and reach out to us. So takes us through to some links for the VMUG stuff. So I do occasionally come across VA admins who may not have heard about VMUG. So there's a link there. So go through to vmug.com if you're not a member of the VMware user group. Very active, very community driven, lots of knowledge sharing. Great place to be if you've got questions. I did touch on it last time, but there is a lot of VCF 9 and new content now in hands-on labs. So that's always worth going and checking if you've not been into the labs for a while. It's worth going back and seeing the new sessions in there. And finally, just spread the word. I think we've got a consistent, really good number of attendees to these sessions. So thank you for joining. Hopefully they are valuable to you. And please spread the word. It's we're here to try and make it all a little bit easier to try and consume these new features as they get rolled out in VCF 9 and just scratch a little bit more below the surface rather than just the headlines which you may see in a blog. So that only leaves me to wish you a good weekend, and on behalf of the UK&I Solution Architecture team, thank you for joining. Goodbye.
Thank you. Bye-bye.